Hey, I'm Vitanis. Ruby is one of the programming languages popularly used for web scraping. It can efficiently handle a lot of scraping-related tasks, which I'll show you in this tutorial. We'll build two web scrapers with Ruby, one to scrape static pages and another to scrape dynamic pages. I'll show you how to make requests, extract the desired data, and save it to a CSV file. So let's get started. To install Ruby on Windows, you can download and run the Ruby installer. If you're using a package manager like Chocolatey, in the command prompt you can run choco install Ruby. For Mac OS devices, you can use a package manager like Homebrew. You can install Ruby in your terminal with brew install Ruby. Now, on Linux devices, you have to use a package manager for your distribution. You can install Ruby on Ubuntu with sudo apt install ruby-full. Once Ruby is ready, you'll also need to get the Ruby packages called gems to scrape websites and save the data. In this tutorial, we'll use the HTTP party gem to get a response from a website. Then we'll utilize the Nokogiri gem to parse the response. And with the CSV gem, we'll export the data to a CSV format. All these gems work perfectly for static pages, but to scrape dynamic pages, we'll need to use Selenium instead of HTTP party. You can find the links to the official documentation of each gem in the description below. So, open up the terminal and install these gems. To use Selenium, you'll also need to have a browser installed on your computer, and you'll need to additionally download and install a driver for your preferred browser, like the Chrome driver for Home or Gecko driver for Mozilla Firefox. Let's begin with scraping static web pages. For demonstration purposes, we'll create a scraper that collects data from books.toscrape.com, a dummy bookstore that has static pages. First, you need to send an HTTP GET request to the target web page. For this action, use the HTTP party gem. With this code, we return the response object that contains many useful properties, such as the response.code that carries the status code of the HTTP request. If you just want to see the HTML code, you can do that with the response.body object. Simply add these lines to your code. Now that we have retrieved the HTML of our target page, we can parse it with Nokogiri gem to extract specific information from the page. To parse data, use the HTML4 module of Nokogiri. If you're using version 1.12 of Nokogiri, the HTML4 module doesn't exist, so you need to use the HTML modules instead. Start by adding the required statement. Next, you have to call the HTML4 module and send the HTML string that's within the response.body. This document object contains parsed data that can be queried using CSS selectors or XPath to retrieve specific HTML elements. We'll use the CSS selectors to extract the titles, prices, and availability of listed books from our target website. First, we'll create a selector for the container that holds all this information. Then we'll run a loop all over these containers to extract data. Each book is held in the HTML element article with its class set to product pod. So, to retrieve all the book container elements, enter this line. We can query the resulting element using CSS selectors to get the specific elements in a loop. The title of the book is in the h3 element. One way to retrieve it is with this line. This code will also return a currency symbol. If you don't want that, you can exclude it using the delete function. For example, here the code returns only the numbers and the period. The strip function removes the line breaks and spaces in the response. You can use the title, price, and availability to create an array, which can be appended to another array. With this setup, at the end of the loop, all information will be available as an array of arrays. So let's add a few more lines to see the entire loop. With this code, we'll scrape the data from only one web page. So we need to figure out the pagination to scrape a bulk of pages. The pagination for this site is a simple numerical sequence that goes up to 50 pages. We can see that in the URL. We can handle the pagination by adding a few more lines to our code, essentially creating a simple loop. So far, we've managed to retrieve the content from 50 web pages and extract the titles, prices, and availability of each book. The last step is to scraping static pages is writing the data to a CSV file using the CSV gem. Let's start with the require statement. Then open the CSV file in write or append mode. It's also a good idea to write the headers when opening the CSV, so let's do that. We'll send an array of title, price, and availability. Then it's time to read the data and write it immediately to at least keep some chunks in the CSV file in case the script fails mid-execution. For static pages, we've used the HTTP party gem. However, it isn't that good for scraping dynamic pages. It doesn't render the page, so all the data that's uploaded dynamically to the web page is missed by the HTTP party gem. So we'll use Selenium instead. As mentioned before, to use Selenium you'll have to have an internet browser of your choice installed together with the appropriate browser driver, as Selenium uses the driver to interact with the browser. In this section, we'll use another dummy website that's dynamically rendered. Before sending an HTTP request, we need to create an instance of Selenium WebDriver for Home. Let's start with the require statement. Then, to make Chrome headless, create an instance of Chrome options and mark it as headless using the appropriately named method. Then, send an instance as the capabilities parameter. With Selenium's get method, you can load the web page that we'll use to extract HTML elements. The driver.page source can extract the HTML, and you can use a particular HTML to create an object of the Nokogiri document. You can query HTML elements using the findElements function. It takes either a CSS or XPath parameter to locate the HTML element and return an array of all matching elements. So let's try to extract the quotes from our target page. Looking at the page through the developer tools, we can see that each quote is contained in a div element with a class quote. In our code, we can simply specify the CSS selector as .quote. The CSS selector for the quote text is .text. To extract the text from the span element, we can call the attribute function with a text content parameter. You can put all of this code in an array, so you'll be able to easily save the data to a CSV file. Our target website shows the page number in its URL, thus you can handle the pagination with the method we've used for static pages. But what if the website doesn't show the number in its URL? Here we can utilize Selenium to click on the next button. So first, we can create a selector that looks for the button, and once it's located, we can call the click function to press it. Again, this website has a total of 50 pages, so there will be no next button on the last page, causing an error. We can terminate the loop using a begin, rescue, end block. Now, to export the data to a CSV file, we can again use the CSV gem. Add the required statement, then create a CSV file with the header information. Run a loop all over the quotes and save it as a row. Note that loading data into memory and then writing it might not be the most optimal approach. We'd recommend writing as you scrape instead to ensure consistency. And that wraps up this tutorial. If you found this video helpful, hit the like button, subscribe, and leave a comment about your experience with web scraping using Ruby. Thanks, and see you later.